Good morning, everybody. We're going to continue with our integration by substitution notes. All right, we did examples 2, 3, 4, 5, and 7 yesterday, the last time we met. And now we're going to finish up a few more similar to what we talked about on the previous lesson, and then we're going to get into a little bit of trig. All right, and then we'll be all done. So remember, we are going to use substitution whenever there is some quantity raised to a power. All right, whenever there's a quantity raised to a power. If there's not a quantity raised to a power, then we're going to treat things like we normally have. All right, so we only use substitution for right now if we have a quantity, which we have here, x squared plus 2 raised to the fifth. So whatever is on the inside of that parentheses, that is going to be our u. So we got x squared plus 2. All right. Once you do your u, then you can do du, which is the derivative of our u. So the derivative of x squared plus 2 is 2x, because that's x squared. 2 is just 0. Remember, we always put a dx after that. Okay. Once you do your u and your du, all right, you then have to look at your du, which is 2x dx. All of this needs to be after your integral somewhere. Has to be in there. Because we want to rewrite our integral in terms of u and du. We need to have du there. All right, which means I need to replace this stuff to be able to write du. So I need a dx. I have that right there. I have an x. Now, I'm missing a what? So I have an x, I have a dx. I'm missing a 2. So I put the 2 in. So now I have 2x dx. So all of this that I'm circling, I can replace with du. So this is all gone. All right. Now remember from the previous lesson, you were allowed to add constants. I just added 2. You cannot add variables. So if this x was not here, I would not be able to do this problem. It is there, so I'm okay. But if it wasn't, I'd be done. All right. Whenever you add a constant, you got to take the reciprocal on the outside to balance it out, to compensate for it. All right. So the stuff that's all circled in red is gone. That's replaced with the du. So I'm still left with x squared plus 2 to the fifth. But what is x squared plus 2 to the fifth? X squared plus 2 is my u, right? That's my u. So I can replace that with u to the fifth. So I just rewrote this whole integral in terms of u and du. Du is 2x dx, right? 2x dx. U is x squared plus second to the fifth, right? This and this mean the same thing. This is just easier to integrate, all right? So now we just do basic power rule. 1/2 times u to the sixth over 6 plus c. And then when I write my final answer, u is what? X squared plus 2 to the 6th power all over 12, because 2 times 6 is 12, plus c. All right, and there's my answer. All right, so now with number 8. We have something being raised to a power, but it's on the bottom. All right, so what do you think our u would be? If you just had to take a guess, what do you think it would be? Okay, well, what's being raised to the power? It's 4x minus 1. Don't worry about that's on the bottom. You'll see what's going to happen to that in a second. So I get 4x minus 1. All right, let me take the derivative of that. 4x minus 1 is just 4, and then I put a dx after it. All right. Now, I need this to be somewhere in here. This 4 does not count. That's in the parentheses. This is going to be our u. All right, that's our u. I have a dx. I'm missing a 4, but I can put a constant in there. So there's my 4 dx, which is really my du. But since I put a 4 there, I need to put a 1/4 on the outside. And what's left on the bottom? U to the third. Now, I don't want to integrate like that. What do I do if something's on the bottom? I change it to u to the negative third. All right, and that is what we're going to integrate. So what ends up happening, since this quantity is on the bottom, just like if we had 1 over x squared, we make it x to the negative second. We have 1 over u cubed, I make it u to the negative third. And when we do our power rule, 3 plus 1 is negative 2. We put it over negative 2. And then we're going to move this u to the bottom. All right, so I get negative 1 over 4 times 2 is 8. The quantity u, which is, what was that, 4x minus 1 to the second, this is all on the bottom, plus c. And there's our answer. All right, so just like we did with negative exponents before, now we just at the end have to substitute in our u. All right. All right, why don't you, for number 9, see if you can get a u and a du for me. Go ahead and try that right now. All right, so what's the quantity being raised to a power? It's 1 minus 2x squared. So that's going to be my u. My du is the derivative of this. The derivative of negative 2x squared is negative 4x dx. Okay. So this one's going to be a little bit different than something we might have seen before. All right. And the fact that we need this in our integral, right? Now, remember, anytime du has a variable in it, that variable must be in your problem somewhere, your integral. Otherwise, you can't do the problem. I need an x. There's my x. I need a dx. There's my dx. All right. There's a 3. I don't want a 3. I want a negative 4. Remember, one of the properties you can do with integrals is any constant can be moved to the outside. So I can move that 3 right there. Now, what do I want? I don't want a 3. I want a negative 4. So I can add a negative 4 there. But what do I need to put on the outside? I need to put a negative 1/4. But there's already a 3 out there. So I'm not going to have just a negative 1/4 out there. I'm going to have 3 times a negative 1/4, which is negative 3/4. And this 4x dx is what? That's my du. Over, what's this? This is my u to the 4th. All right, so let me just go over that again. This 3, I didn't need a 3. You can move any constant outside. Always can do that with an integral. All right, so I move that 3 outside. So it's just like it was x dx. I needed a negative 4. I add negative 4. I put the 1/4 on the outside. It's a negative because I needed it to be negative. However, there was already a 3 out there. So 3 times negative 1/4 is negative 3/4. That's why it's negative 3/4 out there and not just negative 1/4. Once we get to this point, I can rewrite this as negative 3/4 integral of u to the negative 4th du. All right. And then I go ahead and integrate this, negative 3 over 4 u to the negative 3rd over negative 3. Well, look at this. Cancel, cancel. This just goes to the bottom, and I get 1 over 4. What's my u? 1 minus 2x squared to the 3rd plus c. Now, if you didn't cancel them right away, you would hopefully see a negative over negative as a positive, but you would have 3 on top, 12 on the bottom, and 3 over 12 reduces to 1/4. So there's our answer. All right, so for all of the ones we've done up to this point, it's been some quantity raised to a power, and that's what we make our u. Okay. Now, we're going to do a couple of trig ones. Now, up to this point, the only thing we've been doing so far with trig is like sine x, cosine x, secant x, tangent x. It's only been an x after it, okay? Now we're going to have things that are more than just an x. All right. So when we see a trig and we have something besides x after it, we're going to have to use substitution. All right, going to have to use substitution. Now, hopefully you can read that. It's supposed to be sine of 3x. When I went to the PDF, it kind of got messed up a little bit. All right. So anytime you just have one trig function, u is going to be whatever comes immediately after the trig function. So this is sine of 3x. So u is going to be 3x. Whatever comes immediately after it, that's what our u is going to be. All right. Now, once we're to this point, it's the same steps. We're just picking u a slightly different way. But remember, it's what's on the inside. Before, it was a quantity being raised to a power. It was on the inside. What's on the inside here? Well, remember, this is really sine of, a lot of times they put it in parentheses. Well, what's in the inside? Well, it's sine 3x. It's 3x. That's on the inside. All right, so the derivative is 3 dx. All right, it's a little cut off here, but there's our dx. What am I missing? I'm missing a 3. So I add a 3 in there. There is my du. All right, and what's left? I'm left with sine 3x. I'm just going to write that as sine. But instead of being 3x, I'm going to replace that with u. So it's sine of u du. All right. Hopefully you remember the, your derivatives and then your integrals. Remember, the derivative of sine of x is cosine x, right? Cosine x is negative sine x. So I'm trying to do the integral sine. You look on the right side. So I look at sine, which means the answer is cosine. These signs are different, which means these signs need to be different. So that's positive. So our answer is going to be negative cosine u plus c. But what's u? Right? What's u is 3x. Now, hopefully someone right now as you're watching the videos is saying, like, why did Mr. Gillern do something? I think he forgot something. And you're correct. What did I forget? Right? Well, the answer is I forgot. I added this 3 in there. So what do I need to put on the outside? I need to put a 1/3. Right? So that means a 1/3 goes there. Right? So it's negative 1/3 cosine u, which is 3x plus c. Now, if you want to write that as cosine 3x over 3, you can do that as well. Or you can just write negative 1/3 cosine 3x plus c. Both of them are good answers. All right. All right. Moving on to 11. So this is cosine of 2x plus 5. So what's supposed to happen is this 2x plus 5 is inside parentheses. Okay. So we have something besides x after it. So we're going to have to do substitution. What's going to be my u? All right. Well, it's going to be 2x plus 5 because that is what's inside. That's what comes immediately after the trig function. The derivative of 2x plus 5 is 2 dx. I have a dx. I'm missing a 2, so I add a 2, which means I have a 1/2 on the outside. All of this is my du. So that's all gone. What's left? Cosine, which I can have trig in there, it's fine, of u. All right, and what is cosine u? Well, cosine, look on the right side, is sine. So the answer is 1/2 sine u plus c. So I'm going to write it the other way compared to this one. I'm going to write sine of u, which is 2x plus 5 over 2 plus c. I don't care how you write it. If you write it like this or like that, I could write 1/2 sine of 2x plus 5 plus 2. They mean the exact same thing. It is up to you. All right. A couple more, and then we are going to be all done. All right. We'll do 12 and 13. We'll save. I don't know. We'll see. All right. Now, this one, you're like, wait, we have 2 trig functions, secant and tangent. That's okay. They are to the same power. As long as they're the same power, you're fine. We're going to see the next time where we're going to have examples where you have cosine cubed, sine to the first, sine second, cosine to the first. That's going to be something different. But here, even though there's more than one trig function, as long as they're both to the same power, in this case it's to the first power, we're going to make u whatever comes after the trig functions. Notice they're both what? 4x and 4x, all right? So that's going to be my u. My du is 4 dx. All right, so now we're just doing, it's all the same steps. I need to have all of du in the problem. There's my dx. I do not have a 4. These do not count because these are u. All right, so I add a 4. There's my 4 dx, which means I need a 1/4 on the outside. I'm left with secant, but not 4x, it's secant u, tangent u, and then this is my du. All right, and if you remember, the derivative, so the integral of secant u tangent u, what's the derivative of secant x? The derivative of secant x is secant x tan x. All right, so you have to be able to write those 6 derivatives down. All right, so we look here, we go backwards, so the answer is secant. So it's 1/4 secant of u plus c, so it's 1/4 secant of, what's u? 4x? Secant 4x plus c. And there's your answer. All right. All right, why don't you guys go ahead and try 13. So the way this is cosecant squared 8x. All right, so look kind of like that. Secant squared 8x dx. Go ahead and try that one now. All right, so hopefully here we're back to one trig function. It's whatever, it doesn't worry about the squared. It's whatever comes after it. So it's 8x, not the squared, it's just 8x. So the derivative of 8x is 8 dx. I need this. I have to add an 8 in. So that gives me my du. But I need to put a 1/8 on the outside. Well, what's left? Cosecant squared of 8x, but that's u. Well, what's the integral of cosecant squared u? Well, this is where you need to know all those derivatives. And hopefully, if you remember, put this little box, tangent, the derivative of tangent is secant squared x. The derivative of cotangent x is negative cosecant squared x. All right, so I look here at I look at the right side, there it is, it's right here. Cosecant squared x is cotangent. See how these are opposite signs? So these need to be opposite signs. So it's going to be negative 1/8 cotangent x plus c, cotangent u, sorry. So the final answer is going to be, actually, let's do this color here, negative 1/8 cotangent u, which is 8x, plus c. All right. All right, let's do last problem right here is 14. All right. Do me a favor, go ahead and try 14. Remember, this is 2 trig functions, but they're the same power. So what am I going to make my u? Pick your u, du, see if you can go from there. Go ahead and try that. All right. So x cubed, that's what comes immediately after the trig functions. So that is my u. The derivative of x cubed is 3x squared. Okay, now, just like previous problems, we have an x, we have a variable. That needs to be somewhere in my problem. Oh, wait, there it is. There's my 3x squared. All right, there's my 3x squared. There's my x squared. So that's that. There's my dx right there. I'm missing a what? A 3. So I have to add in a 3, which means I put a 1/3 on the outside. So everything I've circled in this reddish color, that gets replaced with a du. So now what's left is the cosecant x cubed, which I can rewrite as cosecant u, and cotangent x cubed, which is cotangent u. All right. So once again, back to our derivatives, secant x all right, as I wrote up here, is secant x tan x. Cosecant x is negative cosecant x cotangent x. So right there is what we have here. So the answer is going to be, once again, the signs are opposite. So it's negative 1/3 cosecant u plus c. So final answer, negative 1/3 cosecant of u, which is x cubed, plus c. And there's my final answer. All right. What we'll do is I will start on the next lesson with 15, and then we'll move on to ones with a little different power. We're just going to switch around what the U is going to be. And that will be our last day of notes with integration by substitution. All right. So hopefully, if you have to, go back and watch the video again. If you're not sure on certain parts, part of your assignment for homework today is to practice some of the stuff on the worksheet that I provided on the classroom. If you have any questions, please let me know. All right. Hope everyone's staying healthy. All right. You and all your family. All right. Have a good one, guys. See ya.